G'day everybody and welcome back to the channel. I'm getting a start on laying the circuit boards out for these amplifiers. So this is what I've done with the little bias string. If I bring the heatsink in situ, it might make a bit more sense. Excuse me. So as you can see, there's pads for all the diodes. And then basically what's going to happen excuse me, is there's going to be a resistor from here to here and another resistor from here to here, and then the same thing here, resistor to here, resistor to here, and then there's going to be a jumper from here to here, a jumper from here to here, and then a pot between these 2 points and these 2 points. Actually, sorry, I've got to add a resistor. So actually I've got to put one more track that will just sort of curl around. Well, it's a bit more complicated than that because the pot's got 3 pins and 2 have got to be tied together, but I'll just do that now. I'll just fix it now on camera. It'll make a little bit more sense because I'm trying to explain it. So instead of one leg of the pot being here and the other 2 being on this track, basically I need a resistor somewhere, so I just need to draw another bit of straight track that I can, if I sort of put Sharpie, and kind of screwed it up. How can I save this? Yeah, that'll work. Alright, so I might tidy that up a little bit more. I'm not too incredibly happy with it, but you know what, if I just scratch some of this back, open this gap up here, it looks a little bit better. Yeah, that'll do. That's fine. So now I can put a resistor from there to there, from there to there, and I can sit 2 legs of the pot somewhere along there, and the other wiper or remaining end of the track there and there. I hope that makes sense. It'll make sense obviously once it's populated, because it's a very simple circuit. This is probably the most simple circuit in the amp. Anyway, so that's what's happening with those. I've now got to do the same thing on this strip. Yeah, I know it's not perfect. I've done all of this by hand. I didn't even measure these, like I literally just cut them by eye basically. If you see, they're completely different and not straight or anything. I just cut a shape. I used a ruler to draw lines and then just tried to follow the line with a Dremel, but even that I didn't put much effort into. And it's kind of hard with a Dremel because the wheel's only that small, so you have to hold it on an angle, and the wheel gets smaller as you cut, so you got to walk the Dremel in at the same. Yeah. Anyway, it's all good. It'll actually look a lot nicer than what it does when it's etched and populated. You'd be quite surprised how things come out. Anyway, so I'm going to go do the same thing to this board now, and then come back and then we'll start populating these boards, which are for the emitter resistors and Zabel network and collectors and all that sort of stuff for the outputs and drivers. So we're getting there. Going to get a move on with building the power supply soon too, because, well, not only I need an output stage, But I also need a power supply to power it if I want to play around with front ends. Alright, well, I'll get to doing this and I'll be back soon. Just one thing I want to go over quickly, because I know some people are probably going to ask, so I'm just going to explain this before the question's asked. You'll notice on this board, we've got a really low, I can't remember what it is, 50 milliamps, 20 milliamps, 100 milliamps, but it's milliamps. It's not much flowing through this diode string, right? Now, the reason the traces are so long is because of inductance. You see, with these smaller boards, the traces will be much, much, much skinnier, but they will also be much shorter. So one thing you can do to minimize inductance is when you've got a longer trace, make it wider, as wide as you can. That will minimize inductance. So that's why those traces are really thick. I've basically gone as thick as I can whilst being able to leave enough of a gap. Put it this way, because the voltage isn't very high, the differential voltage between the traces is not very high at all. It's just a couple of volts. There's not any current flowing through it, and it's not a high impedance circuit. Well, not really enough. You can go pretty close with the traces without crosstalk happening, cross coupling, whatever you want to call it. You can't do this in all circuits. It depends on, the part of the circuit. But for this board, this is what I want to do. I want to minimize inductance down to the point of as much as I can without the traces being too close together, if that makes sense. So, on the different boards, different techniques will get employed, and I'll talk about those as I do them. You got to remember, this is all just me just drawing this freehand too, so, I'm not the neatest writer, drawer, so for my messy hands, this is pretty good. And after all that cutting, you know what I just realised? The cap banks. I need a couple strips to put the 2 rows of 8 capacitors. Oh well. I'm going to do this outside because I'm not cleaning up all this again. No. Alright, so a couple of other things have come to mind. So I've made changes and added it into my schematic. I might want a resistor across the bases, not to shunt away current if there's too much gain to bring the bias down. If there's too much bias current, these 2 resistors here would get adjusted and then it would get fine-tuned with the pot. So the reason, should I say, that I've put a resistor there, that's, let's just say around 10k, because I don't know what the value is going to be, but it could be around there, is to turn the bases off, to stop cross distortion, like both the sides turning on at the same time, at high frequencies. The other thing is I've removed the Miller compensation caps from here and added them here. I don't know why I put them there. I wasn't thinking. They need to go here. So I've moved them back. I'm still contemplating the 4.7 mic and 100 nanofarad cap that I've got across the bases for bias stability. Put it this way. As long as I have all the positions, like the pads and the holes on the PCB, we can go swapping components in and out, have spaces populated or not populated. The problem is if I don't have the actual traces and pads there, you know what I mean? So as long as I get everything I don't miss it anything, you know what I mean? I get it all in here and then make the PCB up. We can change how the PCB is populated afterwards, if that makes sense. So yeah, just thought I'd point that out. Speaking of leaving provisionments, I have seen in quite a few designs where this resistor value is higher than 10 ohms, like 100 ohms, a capacitor across it. So I'm going to leave pads on my board for that too. Because like I said, I want to experiment with these things. I built a very basic version of this years ago. It worked wonderfully. So I know the design works well, but I now want to refine it, you know, build it properly in a case and on PCBs and all that sort of thing. And like I said, fiddle with it and refine it. So I want to leave, you know, spaces where potential components could go or be removed so that I can just, you know, change the way the board's populated instead of having to remake up board after board just to adjust stuff. Alright, I've just added one more provisionment. So with some triple Darlington designs, this is like a form of local feedback, but a lot of the time you'll have a line going back from here connecting to the center point of these two resistors, and instead of a single resistor here, two resistors and a line connecting these 3 points together. So what I've done is I've put a track running through and it'll have opens in it so that I can fit jumpers to close this up or have it open and it's open. Now, when I built this amp years ago, I did tests comparing the performance of it with that closed and open. With it closed, it had less gain, and I think the THD seemed worse to me. That was the measurement I was getting with this particular design. But again, I'll leave the provision there on the circuit board so that we can play around with that. Obviously now I've got, you know, proper equipment in here that I didn't have years ago, and I'm going to get that quantisylum. So I'm going to be able to see a lot of things that I couldn't see before. So I want to put all the provisions for all the different options in my design so that I can play around with it, like I said again, without having to remake up the PCB. You know, come to think of it, since I'm leaving pads here to populate or not populate so I don't have to make up multiple PCBs, I'm going to leave the Miller compensation caps in two different spots. So, you know, I'll have pads for all the components and different layout choices. Do you know what I mean? I mean, aside from it being a triple Darlington, but yeah, that's what I'm going to go with. Alright, I've done some further deciding. These two resistors, not sure if I mentioned it before, but they're going to be 430 ohms. I was tossing up between 390 and 430. It's going to be 430. And the starting value for the feedback capacitor is going to be 2.2 nano, as is the capacitor across here. I'm going to fit them anyway. I'm not sure if they're going to be of any help with that lower of a resistance, but they may. I know if it's around about 100 ohms, they will be of help, so I'll just fit them anyway. Like I said, I'm leaving these extra pads for compensation, and the I forget what you call this, but those two links there too. Should note that this node here joins, as does these nodes, obviously. Right. Sorry, I've also noted the transistors that I have changed to. So basically everything that you see here, as messy as it is, I've got to redraw all this and make up boards for it. Alright, so it's the next day, and last night a few things came to mind. As a few things came to mind, I actually came back in here and made notes and recorded the changes that I thought of, but it then got late and I didn't come in and add the rest. So thinking back to when I built this now, I've finally remembered I ran this without Miller compensation. I remember, it's all come back to me now. I remember I had, when I first built this thing, I had, I can't remember which side, but one side had somewhere around 120, 150 picofarad on the, I think it was on the output stage or the driver. I think it was the driver. And the other side was a bit smaller, like 100 or something like that. Then I remember I removed them and I did some other things. I can't remember exactly what, changing resistor values. I can't remember. But I ended up getting them out, and the only capacitor I ended up having in terms of compensation was this 47 picofarad capacitor on this huge TIP 42C that's acting as a 15 watt Class A amplifier. So that was with that in the feedback loop, by the way. So I mean, obviously who knows how this is going to behave with other input stages, but for now I'm going to leave them out. Obviously I'm going to leave the provision on the PCB to fit them. I've just taken the 2.2 off the page because I'm not going to fit it in the build when I build it, if that makes sense. So yeah, all right. I also have to work out the value of this resistor too. I guess I'm going to try it without that resistor fitted. I remember the one thing I had problems with, surprisingly, when I built the first amp was not oscillation, was not THD problems. It was cross distortion, both sides turning on at the same time with high frequency, which I fixed with resistors between bases. But like I said, the values were a bit too low for my liking, which obviously kills gain by so much. So I never did anything further back at the start, so I'd be interested to see how much of an effect that has on it, you know, and what I can do with these values. Anyway, I'm going to finish making up these boards and we'll be back. I still can't remember exactly what my feedback resistor value was either, but I can tell you now, I think off of memory, it was in between 47k and 100k. Off of memory. I could be wrong. But I mean, it's been a few years. This is all just like slowly coming back to me. I've been reading over some articles on amplifier design, and that's reminded me of a few things too, which has prompted me to come back and look at this and think about a few other things, which has then made me remember how I addressed these things years ago when I designed this. It's all been slowly coming back to me, and I'm just sort of, you know, adding to it. But anyway, that's all I've got to add to that for now. I'm going to get this other board done because I've only done that, and then we'll get started on the output boards. Something I forgot to mention about the output boards, that's these long ones where the emitter resistors will go and all the collectors will be connected together, and the connections between these transistors. Hey, get out of here. Yeah. The other thing that has to go on that board, which I should have pointed out when I was talking about it before, is the feedback path. So where the Zobel network is, where that 4.7 ohm resistor and 100 nanofarad cap is to ground, and the 1.5 microhenry inductor and 4.7 ohm resistor in parallel to the speaker output, the feedback has to come before those components, not after those components. So just something to point out. You'll see when I lay the board out, but I just wanted to point that out. Alright, I'm going to get this finished and then we'll start on those output boards. I think after that, should I say, I will do the buffer boards and then get the power supply built, because once I've got an output section and a power supply, I can start building input stages, having a look at them on the scope, and once I think that they're working, I can hook it up to the amp and actually give it a test. Also, I want to get the output transistors, drivers, and the buffer stage all powered up, biased on, and make sure it's got no problems. And I want to feed a signal into it from another amplifier that I can use as a source, just to test it, you know. I want to run 20 kilohertz through it. The first thing I do when I build an amplifier, first two things I look at, other than component sizing, you know, values of components, is for oscillation, obviously, and then cross distortion. Obviously, you know, setting the bias is the first thing you do, but I'm talking about looking for problems. I like to get, you know, a 20 kilohertz signal, stick it in the amp, turn the amp up with no load on it, feel the output devices. You'll feel them warming up if they're both turning on at the same time. You can also measure this, but I'm just saying that's the thing that I'm going to look at first, and then adjust the resistor values that go between the two bases, and then we'll move on from there. So that's why I want the output stage ready. I thought before I get the next board done, I'd cut the two boards for the cap banks. So now we've got 4 boards, 4 boards, 2 boards, 2 boards. So that's all the bits of PCB, and it allows me to keep it modular and make different boards and try them in the amp, you know. Different buffer stages, different preamps, and I can just swap the boards in and out without having to change the entire amp's design. Those boards are just a little bit skinnier than the other boards in there, and almost the same length. For all intensive purposes they are. That just happened by chance. I actually measured these boards to the cap bank that I'm, like how many capacitors I put on it. I laid how many capacitors I'm putting on the board, so I'm trying to say I laid them out and traced around that and cut the square out, so that just happens to incidentally be the same size. Anyway, that's all the PCBs ready. I'll be back when this is done. Alright, I've marked up the bias boards. Yes, one is slightly different to the other. Let me just get this in a better spot where there isn't a whole crap ton of glare and lock the focus. Alright. I did this top one first. You know, I tried to get the traces a little bit thicker on this one, and it just resulted, you know, I'm doing it freehand. It just resulted in it coming out slightly different. It's the exact same thing. If you follow all the traces, they all do the same thing. Like this trace comes out here, a resistor jumps over there, and a resistor jumps over there. You've got a pot with a wiper on one end of the track on here and the other end of the track there. You've got a resistor here, a jumper here, and another resistor here. And then it's just the same on the other side, basically. It'll make a lot more sense once it's etched and populated. But it's a very simple circuit. So now what I'm going to get a start on is the capacitor bank board and the output boards. I think I'm going to do the cap bank first, just because that was a little bit more fiddly. I want something easier to do for now. So I'll do this, and then I'll go back to something that's a bit more fiddly, the output boards. So I'll get these done now. Now, something I want to talk about, because whenever I do boards and I want to do straight lines, especially if I need to get traces close together, I struggle, because what I find happens is when I use a ruler, and I can't remember if I talked about it in this video or not, but it happened on this board. That's why you can see all these bright areas where I had to scratch to get everything perfectly neat. I had to scratch ink off, you know. I couldn't. When I draw a line across the ruler, what happens is, due to capillary action, the ink goes under the ruler, it gets sucked in, and then I don't end up with a straight line. When I lift the ruler up, there's all ink everywhere. So I have yet to work out a reliable method of drawing a straight line on a PCB. I can do it with a ruler. It's just like every 1 in 3 goes, it's messy. Even the perfect one's still got a little bit that I end up having to fix up, you know. It's just, it doesn't seem to work for me. So yeah, anyhow, I'll get these done and I'll be back soon. Well, 1 down, 1 to go. I just want to point out, you could use tape to do this. So the only tape I've got that's narrow enough to make this track is Captain tape. Now, Captain tape costs a bit. I think this little roll is still about $12 or $15 a roll, something like that. Might be even more, 16, I can't remember. You know, so I don't really feel like wasting it. That's why I've done it in texture. Plus, this is thicker than the trace anyway. But just wanted to point that out. That's what I've done with this little RF amplifier PCB that I screwed up by etching the back of it off when I was supposed to leave the back on. The second board I've covered with a huge piece of sticky tape. I know you can't see it looking through this, but I can assure you I have. It's got a huge piece of this over it, packaging tape. So just, yeah, food for thought. It's something that you can do. It does work, but I'm drawing it with texture because I don't want to waste Captain tape, and plus the traces are a little bit narrower. I could make them thicker, it's not a problem, you know. I could use the tape, but yeah. Anyway, I'll get this done and I'll be back soon. Something else that I just changed. I know I keep making all these little changes, but anyway, I've added 1 microfarad 100-volt MKTs in parallel with each rail, just for high frequency filtering. You know, little noises, pops, and high frequency noise and stuff that is on the line. Anyway, and the other thing I wanted to point out is that here, these 2.2 nano capacitors, and the capacitors that go here, if we do use Miller compensation, they're NPOs. Just wanted to point that out too. Right, so I just went up to Coles to do my shopping, and I grabbed this whilst I was up there, because this, well, if we compare it in size to my normal etching container, we can etch much bigger boards in that. Now, it's not, you know, the size of this whole sheets that I can buy. Just don't want to get my oils on that. No, it's already messed up. You know, I can't fit a whole one of those in there, but I mean, what am I going to want to make that's that big anyway on a PCB? So this is quite good. you know, this is going to be sufficient for building amplifiers and even maybe a power supply, or, you know, I can think of a few things that might take some fairly large boards. This box will do the trick. Quite a bit of space there. For those that are wondering, we've got 31 centimeters long and 24 centimeters wide. So we can do some pretty big boards now. Alright, that's the two bridge rectifier boards and the bias boards done. So now I've got to work out the output boards. So I think I'm going to draw these on paper first, just to experiment with a few things. But basically the output boards, one's going to go there and one's going to go there. There's a little lip under the heatsink there, you see. And basically the PCB is going to be roughly in the middle, if that makes sense. I want it close up to the bottom of these thicker bits on these transistors. I'd go up higher if I could, but you know, I don't want it too close to the metal of the heatsink. So it's going to go about there. That'll be sufficient. So that's how they're going. I think what I'll do is I'll sit here, work out how I'm going to do it, draw that on paper, come back, if you guys look at that, and then I'll start, what do you call it, making the design on the board with Sharpie. Alright, this probably isn't going to help too many people because I literally just started drawing transistors and then I was like, okay, I want something the same size as the board, so I just drew a square, a rectangle, should I say, traced around the board. Obviously, this is not to scale. I'm going to use up the size of the board and make the traces nice and fat, but this is what I'm going to do. So the dotted line is a link, like a wire link that runs above traces. So there'll be a link from collector to where the collectors of these two transistors are tied together, roughly the center point, right next to where the power wire goes to it. Same on the other side, two collectors get tied together. Power wire goes there, link goes there to the collector of that. Emitter goes to, I don't know if I've done, oh, it's there, sorry, to the two base resistors, to the bases of those transistors, this emitter, base resistor, base resistor. The emitters of the output devices, they got their emitter resistors, and then those 2 points come down. You've got your inductor, your resistor, your capacitor to ground. Again, inductor, resistor, resistor, capacitor, ground. Output from channel 1, output from channel 2, and the bases are also just going to bugger off to a pad for a wire to connect to. So it's going to be something like that, if that kind of makes sense. Not a lot happening, but going to be a chunky board because it's got to carry a bit of current. So I'm going to get to making that now. So I just wanted to do that so I could have a play around with, you know, what traces I'm going to put under a resistor, where I'm going to put a link, stuff like that, move stuff around. It doesn't need to be to scale. It's just so I can look at it and remind myself what I've decided to do, if that makes sense. So that's all that is. I'm now going to do that to 4 of these and I'll be back. First thing I've got to do actually is I want to mark up where the pins are going to sit roughly. Basically like that. I'll have the board out a little bit more. So sort of like that. And I'll mark where the pins are, and then I can take this out and start making traces. So I'll get this done and I'll be back soon. I've just made dots where all the pins are going to be located. God, that table looks terrible. Got a couple of little sleeping kittens in here. Watching, I guess they're not watching, are they? Sleeping whilst I work. Well, I've encountered my first problem. You see, because of the way this is designed, the thermal tracking, the way I got this to work so well is by having all of the the NPN devices on one side and the PNP on the other. Now, that's not how you normally build an amplifier, which is why when I drew this, I just went and drew it like you'd normally have an output stage. You'd have your two NPNs there, your two PNPs there, your PNP driver there, your NPN driver there, diodes on top or a VBA multiplier in the middle. You know, you'd have your emitter resistors there, your output would be in the center, you know what I mean? I started drawing two outputs, and then I went to put Zabel networks as if it was two channels, and then I just realized something. It would be one channel, but it's not. It's half of a channel. So I completely screwed that up. Like that. I got confused because it's not a traditional output. Like I said, the whole NPN side is on one side of the heatsink and the PNP side's on the other. You know, so now the problem with that is this. All of this stuff here that I am removing can't go on this board like that. So now I've got to come up with a solution for this, because these are the two NPN outputs of each channel. And likewise on the other board, you know, the other two outputs, the PNP half, the other two outputs from the PNP side will be there. So the thing is, what I kind of need is a link like this. You know, and that would be my, this is where I would put my resistor, capacitor to ground, resistor, capacitor, ground, inductor, inductor, and this would be my two outputs. So now I'm thinking, well, what do I do? Also, I have this whole unused section of board here, because and the other thing that this design has, that this is just the way I did it in the first place, and it worked really well. Each group has got its own wire coming up from the capacitor bank. So there's, you know, there's two positives coming up to the board, one for one channel, one for the other channel. I did that so that any differences in current between the two channels, say one channel's playing a drum beat and the other channel's playing a hi-hat, and the drum beat's obviously pulling big current pulses, or the other channel's not going to see the current pulses on its piece of wire that supplies current to it. You know what I'm trying to say. That's why I've done that. Anyway, so that's why they're separate electrically, and that's why the diode, that's why the NPN side's on one side and PNP is on the other for thermal tracking reasons. But it leaves me trying to work out where to put the bit that joins them. So I'm thinking now about cutting a little piece off of each one of these boards, you know, and then making like a little board in the middle of the two to house this. I've got some thinking to do about this. Yeah, I could change the design of the amp. I could quite easily just move, you know, half of this to here and half of this to here, and that driver there and that driver there, you know, but I found that the thermal tracking works perfectly like this, and I tried it in a few different ways. Like, where's the heatsink that I first used? I can't show you this because I don't have the original transistors on here, but I tried gluing diodes to the actual transistors. I tried mounting devices on top of the transistors. I tried some like VB multiplier networks in different spots. I think on the front here on one of these holes, that's why it's a bit buggered up and retapped, and on the top. But anyway, and then the diodes, the same thing. When I ended up working out the positioning of these, I can't remember exactly what I did. I remember I had them held down to the heatsink with something, and I was moving them around, and you know, I ended up choosing this spot. The two above the drivers, I just put them there because I wanted them above the drivers. But these two, I was trying to find the spot where the temperature's the highest in between here and here, if that makes sense. And I found that it was here and here for each pair. So like the hottest area of the heatsink for this pair was right here, and the hottest area for this pair was right here. So, you know, like that's just the way it worked out. So I'm not going to change it. So yeah, I probably am going to cut these shorter and make up another little board that will go in the middle somewhere, which will just have that on it, you know. It'll basically be a rectangular sort of board like so, and it'll have a couple of points on each end of it. Yeah, 2 points on each end of it, where these 4 lines will come in from. And, you know, basically, I haven't even thought about how I'm going to do this yet. I'm going to need to lay out these networks, one for each line, if that makes sense. Yeah, I might make the board square or rectangle, a different direction or whatever, you know. I haven't thought about this yet, but I need to come up with a different plan. It's time for plan B. This works for me, so I'll just show you what I've done basically. The emitter resistors will go here and here, and the power trace will sneak under them. Yes, I could have put the board further into the heatsink and run power traces behind. Yeah, I have actually thought about wiping it off and starting again, but honestly, it's all right. It's just an output stage. It's not like the traces are so critical here. So anyway, emitter resistor 1, emitter resistor 2, emitter resistor 3, emitter resistor 4. And then the base resistors are just going to solder between here and here, here and here, here and here, here and here. And then the other side of this tab will have a link going back to here. Likewise with this, bit of insulated wire. Same with this tab and this tab, bit of insulated wire going back to this here. The base will have a resistor and then a wire coming from the buffer board. That's something else I've been thinking about doing too, is because the buffer circuitry is pretty small, I was thinking about potentially putting the buffer circuitry on these boards. It's probably doable. I've got a little bit of thinking to do, put it that way. Let me think about this. It would only be half the buffer circuitry on each board. Yeah, that's not going to work out too well because that's a higher impedance circuit, and then I'm going to have long wires joining two halves of the circuit together. I think it's best if I just shorten these boards up, stick with the original plan, and just add a little board in between the two that sort of houses this. I'm sure I can make it work. Yeah. You know, I could sort of put one coil like that and one resistor like that and have a pad there, and do the other one like this, you know, and have the other pad there. And the other two components, I guess I could say, you know, like stand the resistor up on its end so it's, you know, it's only taking up this much space. And then maybe have the capacitor next to it. I don't know. I guess I could have these further spaced out, which would give me more space in the middle for those components. I can definitely do that. That's what I'm going to do. I'm going to have to cut these boards smaller and make up a extra 2 little boards that will go in the middle. I think that's... I'll just pause the video and I'll go get some board ready, because that's what I'm going to have to do now. Well, I have this off cut here. This is basically perfect for the job. I'm going to cut this down, and I want the board to be probably, you know, about as wide as this board or a bit wider. So there's, you know, at least enough there. Probably not wider, probably the same width. I mean, let me just grab one more thing. Sorry. I mean, oh, you know what? I'm forgetting another component. Okay, maybe I will want it this big, because I don't want to put the resistor through the inductor either, because you end up with steel inside the inductor, and that's not good. One of these, in series with one of these, I'm going to need a bit of board, eh? I've got a bit of thinking to do. The other option, and this is something else I was thinking about before, is if I could somehow, between the two boards, using this section, house these components. But let me get another sheet of paper. Actually, to stop wasting pages, I'll do it on the same sheet, just on the other side of it, because this is just going to be scrap. Let's get a couple of these just for reference. Don't worry about it. one or two. Just so I've got a bit of a reference, you know. And that's where our emitters get summed up. So, how could I take, you know, I will just draw the other board here. It's going to be a lot easier. So if I sound tired, it's 12:30 and I am actually getting tired. I'm going to stop and call a night very soon. All right. If I can somehow take you know what? We can make this work. Because the thing I'm thinking about is I need it exactly in the middle. You know, I don't want, you can't have the network right next to the PNP side or right next to the NPN side. It's got to be in the middle of the two. And you've got to take your output off the middle of the two also. So what I'm trying to think is this wire that I've got to join between these two pairs, right? All right, let's just draw some wires in first. Easier to visualize it, won't it? Now, the midpoint of this pair would be here. Let's put a dot there. And the midpoint of this pair would be, say, here. So we do have access to the midpoint of each side on the boards doing it like that. So that's good. And, you know, if we're slightly off, we can always make one trace a bit thicker than the other trace to compensate for the difference in length to make it even out. That's not a problem. So, okay. How can I now make this work? I'll tell you what, I'll pause the video, I'll do this off camera and I'll come back and I'll show you what my solution is. Surprisingly, I came up with a solution. Look, I take a trace off of here. I'm going to have to put some sort of a jumper either for this trace and lay this on the board, or lay this on the board and have a jumper for this trace. That's okay, I don't mind that. You know, it's going to be a bloody thick jumper, like at least as thick as that, so it's not going to electrically make a difference. And look, that resistor will fit there, that inductor will fit there. So I can put my output here at the end, and that leaves this space here to mount these guys on that same trace, you know? So we've done it. I'm going to fit it on the two boards I've got without having to make up another board for the middle. And you know what? It'll probably actually make the board look a little bit better because it won't look so bare. So what I mean is trying to split it up and have those components on another board in the middle, it's going to make this board look kind of bare. Having more stuff on it, it'll look better too. I'm not doing this for looks, as you can probably tell. I mean, when I do something for looks and I want it to be neat, I'll sit there and take my time. Like here's a little example. Like I know I screwed this up, I've got to redo it, but I think you can see a difference. You know, it depends if I think I'm going to be looking at it or not. And, you know, this is going to be inside a box. I'm building these properly on PCBs and inside a case, so I'm never going to look at the board unless I've got to fix it really, you know. So I'm not too worried. I don't want it to be ridiculously messy, you know. I'm trying to take pride in your work, but I'm not going to sit here and use a ruler for all these traces, for example, you know. I'm happy with this. As long as it doesn't look terrible and electrically it's good, I'm happy with it. So I'll get this onto here now. Basically, I just got to sort of work out where these traces are going to go, how close I can get them in, what I can do. Actually, that's just giving me another idea. I'm going to experiment with a bit of layout off camera. But I think I might actually move this trace. Oh yeah, I'm still going to have to jump over on one side. Yeah, no, I'm going to stick with this. This works good. One output there, one output there. Right, so after placing the heatsink up here and having a look, there's not much space between the two boards. So yeah, this is going to work fine. But one thing I am going to do slightly differently to what I just said. These two components here, it's ideal to have them as close to the output of your amplifier as possible. So I'm going to lay it out like that instead of picking it up. That was just stupid anyway. I mean, like I was just trying to fit stuff on the board, but that's how it's actually going to be laid out in reality. So, okay, I think I've got a design. I'm going to do that now. I'll be back soon. I really do need a CNC. All right, problem solved. So this will fit here. Likewise, the resistor will fit next to it. All right. I just don't want to put them on the board and scratch it, but you can see they fit there. One of these resistors will sit across there. The capacitor will sit across there. That's it. And I decided not to use traces for going across, but wire instead, and here's why. I can cut the wire to length, measure it with a milliohm meter, and make it the exact same resistance from here to here as it is from the P&P side to here. That's what this block is for here. It's to connect on one end a wire going from here, and the other end is from, like here on the P&P side. And I want both of those bits of wire to be the exact same resistance, which is easy when you're using a piece of wire. I mean, it is with a trace too, but I'd have to measure the trace, and I mean, it's a bit hard to do that when you still got to etch it. I have to take a guess, make the trace a little bit bigger, and then, Dremel a little bit off at a time or something like that to get the resistance where I want it. It's just a lot easier to cut a piece of wire. So I think that's what I'm going to do. And there's just this little bit of space in the corner that's unused. This is where the speaker output's going to come from, obviously. So that's what I'm going to do. So now I've just got to do it one more time. Sorry, 3 more times. I know, it's not my best work, but it's going to do the job. I think what I'm going to do is do like 1, 2, 3, 4, 5, 6, 7, 8 at a time. Might as well do it in a batch. I mean, I wouldn't try this with the ammonium persulfate because everything turns to shit with that. But with this stuff, it's pretty workable. And, if something did go wrong, I could always take it out, fix the board up, clean it up, fix it up, put it back in. Yeah. So I'm just going to go for the batch effort. So we'll see how we go. I'm going to make up the other 2 output boards and tip that in there and some more of that. and get this going. Haven't thought about how I'm going to heat it yet, but I've got a few ideas. That kind of sounds contradictory, doesn't it? You know what I mean. You know, I'm just going to say it. When I've got to do this many boards, I don't like it. I'll be honest. So when I've got to make, you know, 1 board or 2 boards, it's just, I'll give you an example. I enjoyed making this. When I needed a second one, it kind of got boring. Does that make sense? I enjoyed designing this. I enjoyed playing around with it, getting all the parameters right and stuff like that. When I had to do it again, I don't know. It just, I would rather design boards and then, you know, what do you call it? Use a CNC or a PCB service to get them done. Just noticing these are covered in some sort of residue. I cleaned them off with PCB cleaner. I think I must have walked out the room and left it because there's like a white dusty coating over the entire PCB. Not to worry, I can clean that off very easily. But yes, so it is what it is. I'm going to continue, but I was just taking these 2 boards out of the bag because I've kept all the boards facing each other and in the bag so that, you know, they stay nice and clean. And I saw those 2 and these 4, and the first thing I said to myself was, wow, another 6. Yeah. Oh well, at least they're not all the same, but it is a little bit too much replication, duplication, whatever you call it, doing the same thing repetitively over and over again. For me, anyway. I have to get it done, however, so the amps are not going to build themselves, and I want them built. So I've pointed out tips and tricks in some of my videos for how I get the designs on the board and make them, but I've just found an even better way because, as I've explained, sometimes I'll dab a Q-tip with IPA or something like that to get rid of some ink. Sometimes I'll scratch it off with a little scratchy bit or some scissors or just whatever's lying around, a bit of metal. I tried the carbon fiber brush, best result ever. I'm not going to have any circuitry over here. I'll just give you guys a look. I just want to make sure the ink's dry first because you won't be able to tell how well this works if the ink is still wet. Alright, that ink's dry. Yep, that's it. I'll just give that a little wipe. Now that might look dark on the camera, that's only because I've scratched it. There's no ink there, see? So new technique for removing Sharpie. You can scratch it or you can use IPA. I just had a little consideration come to mind. Remember in the schematic I said I'm going to leave these points here open so that if I want to close it up, I can. Well, I'm going to want a location on this trace here that I can solder a wire to that goes to the buffer board. So to, what's the word? Gosh. You know what I'm trying to say? To accommodate this wire, I think what I'm going to do, because the way this is going to be laid out is going to be 3 holes here for 3 big wires. Wait, 3 is it? Hold on. 1, no, two, sorry. Two big wires go here. So actually the third wire could go there. I don't need to add any extra holes. Never mind. Screw what I was saying. I was going to just add like an extra black square here or here, you know, but actually there's more than enough room to fit 3 wires. So let me just think about this for a moment. That's all it needs to be there, right? 2 wires. You've got your NPN side goes to there. Your PNP side goes to there. Disable network output. Yeah. RC to ground. Yeah, no. So I can fit 3 wires there. That's fine. So I'll just drill 1, 2, 3 holes on those black lines. All right. That was a pointless thing. I'm still going to leave that in the video because I want to point out the fact that like there is going to be a spot for that wire, if that makes sense. So in the future, I don't know, it might make a bit more sense to people. But anyway, I'm going to finish these last 2 boards. I think I'll be able to fit them in the box. I'm not sure. Let's see. Let's see. How many boards can I fit in here at once? Yeah, I think that's what we're going to... Now I've got to check all the ink and make sure it's not scratched. Okay, we're good. Yeah, so I'm going to get the cap banks, the bias boards, and the output boards done in one go, which is cool. I'm happy with that. All right, I'll be back soon once these are done, and we'll etch them up, and that'll be it for this video. I think it's probably long enough. All right, so that's the first batch. I'll just stand over here to get that glare off the board. So that's what I'm going to... Oh, God, there it is again. You know what? We'll just... Shit. Whoops. There's a couple of kittens there. That's so cute. You know what? No matter where I go, this glare is going to be here. My apologies. Anyway, I'm going to get these done and then start designing the buffer boards and the preamp boards. It's the buffer board and the preamp board that there's going to be some changes having to be made on, so that's the ones I'm going to have a think about. Incidentally, I got some good news. I can't think what today is. I know it's Monday or Tuesday. Gosh, I'm having a silly moment. My drill bits are going to be here on Wednesday. I'm pretty sure it's the day after tomorrow. Yeah, the day after tomorrow. I was right. Today's Monday. So 2 days, we'll be able to drill all the holes in these boards, and the RF amp will get finished. Actually, there's 2 of them. So I'm very eager. Alright, I think I'm just going to be patient and just do it without heat. It's just going to take longer. It's still going to work. This is fresh ferric chloride. I'm just going to put some of that in first. I am going to put this other stuff that I've already used a couple of times in here. Well, you know what? I'll keep it separate. I'll keep that for little boards, and I'll keep this for the big tub, just so if there's any contaminants in it, it doesn't mix. Because I don't know if anyone watched the video, but when I etched that little differential amplifier board, the one that I etched the back off of it by accident, I had a problem with one corner of it and all the Sharpie disappeared. So I don't know if that's dissolved into that ferric chloride, and if it is, that would really suck if I put 4, 5, 6, 7, 8 boards into it and that dissolved Sharpie started breaking down the new Sharpie and I ruined all those boards. So we'll do this, you know, and then I'll just keep this for little boards that I do in that little bath. I need to get a new pair of those plastic tweezers. I keep forgetting. You know what? I'm going to order some now. Well, I can't order them right this second because I'm recording video with my phone, but I'm going to leave these on the table so the moment this is done, I look at them and go, hey, I need to order some. You know what? We still need a little bit more. Might as well just put it all in. Right. Now we wait. Need to get something to grab the boards out with. Great. I'll go sort something out, I'll be back. Well, I just put some electrical tape around those so they're stuck together, but I can open them and they just shut on their own. This will do until a new set comes. I'm going to order some today, so I'll have a new set within a week or two. If I go to JCar and they sell some there, I'll get some sooner, so we're not going to have to wait. You know what's good about having this tub? I can put the lid over it. I'm obviously not going to put it on so I can off gas, but now I don't have to worry about all the cat fur and stuff landing in this, because I've noticed, I mean, I do have a lot of cat hair floating around in the house, especially in between vacuuming, but I've noticed a lot of hair lands in the FC solution and I just don't like it, so this will help. I'm actually curious to see with it cold how it's going. You know what? I think it's going quite good because I can see black everywhere. Yeah. I've got a bad feeling that I've got a board underneath a board. So I've moved it over here, and no, there's no boards on top of boards. What I was looking at was the label on the bottom of the container in the center. With the board sitting on top of that, it looked like a board on top of a board, but no, everything's actually good. So I've got to be careful agitating the liquid that I don't get boards on top of each other, but other than that, it's going great. I also took a board out just to have a quick look at it, and it is working without the heat. I can tell it's looking at it, it's going slower, but like I said, it is working. Now, this is going to work quite well because I cleaned the PCBs up with my old method of cleaning boards. I haven't done this for a while. I don't know how I forgot about it. I've just tried cleaning them so many different ways that I forgot the original method that I used, which actually works better than all the other methods I've chosen. This stuff here, electronic circuit board cleaner, I'll tell you what that is in a sec. And one of these green scourers, oh my god, I just dropped so much fluff in there. Does an amazing job at cleaning the circuit board up. It doesn't react with the Sharpie, and it doesn't cause any problems etching it with the Sharpie coming off. You don't even have to wash it off afterwards, you just have to dry it, so it's really good. What is it? Let's see. I thought it said on the back. No, it doesn't, this one. It just says that it's a blend of highly refined solvents designed to remove flux and contaminants. So, some solvents. Anyway, it does work good, that stuff. I'm an impatient person, and I can just tell that this is going to make me impatient without the heat. It's just the amount of time it's taking. A couple of bubbles here. That was odd. They were kind of stuck to the circuit board, so I wanted to pop them without touching the circuit board too much so that there was no air. They were literally stuck to the circuit board. It kind of looked like no ferric chloride was able to get to that area, if that makes sense. Alright, I feel like this is going to get boring. It's getting boring for me. I'll stop the video and I'll come back when we've either finished or made some progress. So that's the PCBs all etched up. Actually, what happened is it took a really long time. I ended up taking it to the bathroom, putting it on top of some hot water, got it way past the temperature that you would normally just warm up FC2. You don't really heat it, you just warm it. I got it, you know, towards hot, and it completely came to a stop. So apparently what you saw me tip out one of those bottles into that tub, which was about 2/3, 3/4 of a bottle, was enough to do this much. I had to go and tip in an additional, that's why the other bottle's lid's cracked. I had to go tip in an additional maybe 1/3 of a bottle to get it to start going again, and then it finished. Excuse me, then it finished. So I might have another etch, you know, like a small board, like one this size left in that. And I've got a little bit in the bottle and a little bit in the jar, but yeah, gonna have to get some more ferric chloride soon. Anyway, I'm gonna clean up the Sharpie with all this tissue and IPA now, and I'll come back and show you when it's done. You know what, if I might say, yeah, that sounds right. If I might say, these have come out a lot better than what I expected, considering I did it freehand and none of them are exactly the same. You can barely tell just on first glance. And I'll tell you now, when the components are on, it'll look even better. So I'm happy. I'm going to call that a win. I'm also going to end the video here because, well, it's gone on for long enough, I think. I've got quite a number of segments to splice together because I've done this over a couple of days on and off. Also, I've got to start designing the buffer board, because I'm not going to just do it exactly as it was. I'm adding a few things to it as I've discussed, going over the circuit diagram, so that's going to take a little bit of time. Also, I have my drill bits arriving on Wednesday. That's the day after tomorrow, so I want to get my RF amplifier PCB etched up too, so I think I'm going to put this aside and start on that PCB now, and then get back on with this tomorrow. That way, when my drill bits arrive, I can drill the vias for, you know, the amplifier, all the amplifier boards, audio and RF. So, with that said, I'm going to leave the video here. Anyhow, thanks for watching. If you've got any comments, leave them down below. And I'll see you all next time. Thanks.